Hi, my name is Bruce and this is a video about how a collet closer works. Here is the drawing from the parts manual for the collet closer, and it looks kind of complicated, but it's relatively straightforward, and the critical parts are right in here. This part here is called the clutch cone, and this part here is called the clutch finger, and that is the key to this apparatus. This is the clutch cone, and it's hard to see on camera, but inside here there is a recessed section, so it's conical. There's a cylindrical portion here, and then the diameter gets bigger, the internal diameter gets bigger down into there, and that's the clutch cone. Now these fingers run on a pin and they sit in that cone, and then when you pull the cone back, the finger lifts up onto this surface right here. You pull the cone back and you can see the finger just doing a little lifting. So here is the assembly stripped down to its bare essentials. Here is the clutch cone, and here is the mounting for the clutch fingers. So when you move the clutch back, you can see the finger just in there, and as you move the clutch back, it rides up that cone, and notice the gap here between the main body of the collet closer and this ring, this notched ring. As you pull the cone back to its lock position there, the clutch finger is pushed down, it levers the body of the collet closer, which is attached to the draw tube, away from this ring, which is attached to the spindle. So basically you're pulling the draw tube by levering on the spindle. Here it is without the cone. Here's the finger. It would be down in a position roughly like this, and it's going to lever on this notched ring. So I'm going to simulate that by pressing down here, and you can see the gap open up over here because the draw tube has been pulled and the collet is pulled into the holder receiver at the other end, at the headstock. So you can see push down on the finger, and it levers the draw tube away from the spindle. Here I've moved the body of the collet closer away from the notched ring, and you can see in here that when the finger moves down, it essentially pushes outwards against the notched ring, which is the spindle. The purpose of the notched ring is simply to key the body of the collet closer to the spindle. This notched ring is keyed to the spindle. It cannot rotate. That's the key slopping there. But when the spindle turns, the notched ring turns. There is a latch here on the body of the collet closer, which drops into the notches on the notched ring. Now the collet closer is locked, and that means that the draw tube cannot unscrew from the collet. If you unlock it, now you can unscrew the draw tube, in fact, from the collet. And out comes the draw tube. So really that's all the latch is for, and that's all the notched ring is for. Here is the notched ring. It's just a slide fit on the end of the spindle. There's a keyway there, and then in the notched ring there is a pin key, I suppose, right there. It's just a pin with a slightly rectangular shape, and that just slips on the spindle, and really the only purpose is to make this notched ring keyed to the spindle, so that when the spindle turns, the notched ring turns. The bearing runs here on this journal. I'm not going to put it on because it's too tight, too close a fit, but that's where the bearing goes, just a deep groove ball bearing, and then that's what enables a stationary device, which is the lever, to get hold of the collet closer and pull it back. Oh, bearing is going on, look at that. There we go, that's where it sits. Then there's a nut here to retain the bearing. You don't see the guts of the collet closer normally because it's covered with a ring, and this is the ring. This one is very worn, polished, smooth, all the black coating is off from people's hands, and it is bolted with these bolt holes to this stationary part of the collet closer, so it just slips on lining up with the, it's a close fit, so I'm not going to push it around, but it basically just slips on like that. You can see the slot here where the detent latch goes, and bolts to the solid part of the collet closer, and then this is supposed to be what you use to tighten the draw tube. There's one more important component here, and that is you need to stop the clutch cone from going too far. What I mean by that is when you pull it back, that's in the locked position now, so the finger is pushed down as far as it'll go. It's clamping, it's pushing against the notched ring. But if you go too far, the finger falls out, and that is now unlocked. There's no pressure here, and the collet is loose. So that will be somewhat disastrous, and also this assembly could come right off the end of the shaft, possibly while it's running, so obviously that's no good. So what you need is a stop ring. Here is the stop ring. It's just a ring that slips on the shaft, like so. And then there's a circlip, a spring. This is an interesting spring circlip, I don't know what you call that, which goes in the groove here, and then this ring cannot come off and stops the collet closer from going too far and from the finger from disengaging. So that's important. In case you're wondering, this one has a fancy surface finish. No idea why. This lathe is 1974 and has had a hard life, and somebody looks like has put set screw marks all around the OD of this. I don't know whether that's just a cheap way to knurl it or something so they can grip it. I don't know. It's weird. The clutch cone is keyed to the draw tube. You can see inside the clutch cone the keyway, so that it will rotate There's the key. so that then the whole assembly rotates with the clutch cone, rotates with the draw tube, and when everything's locked together with the latch, everything rotates together with the spindle. The fingers are simply pivoted on a pin, which is a push fit in the body of the collet closer. This one's half in at the moment. It's just for my machine, this is just a 1/4 inch, 1 1/4 inch long dowel pin. And then the latch is also on a pin. This one's 3/16 by 7/8, and not installed at the moment, but there's a detent underneath it so that it's positive click into this position and click into this position, and not in between. The bearing on the draw tube rides in this yoke, and it's retained by these what they call swivel blocks, and they grip the bearing and enable you to push it back and forth, pull the draw tube back and forth. But there's a problem here. These are thrashed to death. I don't know if you can see the wear and tear on those, because the bearing has spun. And if you look, there's a threaded hole here, which is aimed at the very corner of the bearing outer race. And what that's for is an anti-rotation pin. You just thread in a 10 by 32 screw and put it in a dog-pointed screw, and then you put it in the notch in the bearing. The only problem is somebody's changed this bearing and there are no notches. So the bearing spun, wore these all to bits and pieces. So made a couple of new ones. The parts are pretty expensive, if you can get them, and I'll notch this bearing so that the anti-rotation pin can work. So that's how it assembles. You can see the swivel blocks allow the bearing to swivel, because as the yoke turns, the bearing needs to stay parallel with the draw tube. There's a spring washer in here and behind the swivel block and the yoke, to stop vibration and looseness this way and keep these swivel blocks pressed in contact with the bearing. What was in there were these. It looks like a plain washer and it's paper thin. Might have been a cone washer, I suppose, but what I've done is put in just some wavy washers, which is what I had. They're much smaller bearing area, so they might wear the parts. We'll have to see how that works. This is the clutch cone, the conical section, and you can see that there is quite a lot of wear just here, here, and here, in three evenly spaced places where the clutch fingers or pawls ride. And you can feel, there's enough wear that you can feel it. This must be hardened, and so are the fingers, but even so there's wear that you can feel. So I'm going to assemble it like that, no problem. I don't think it will be a problem, but if it is, what you can do, this clutch cone is keyed to the draw tube, so all you need to do is cut another keyway in the draw tube and mount the cone on a slightly different angular position, and then you'll be into clean new material, a new section of the cone. The mounting of the yoke is quite interesting. This is the swivel arm that mounts to the lathe, and then the yoke mounts on that, like so. But you notice it's not a good fit. It's a very close fit on the lathe at the other end, so that the weight of the yoke is taken by the arm and not riding on the bearing on the draw tube, which is probably a good idea. And then this sloppy fit here, well, in the top of they're blind holes, but they're tapered. There are conical, and there are these, they call them pilot screws. It's just a hex drive with a pilot to match the taper in there. So what happens is that goes together, this screws in here, and then by adjusting top and bottom you can move the yoke up and down to get the center height right. And then you've got the weight supported and it's on center. Pretty good design. all of this spins with the spindle, so it's a little bit of a hazard for body parts. Most lathes these days would have a cover that's mounted on the this arm, and it just flips up and down and has room for the handle of the collet closer. So to adjust the tightness of the collet, unclip this latch and then rotate this ring. Whoops, have to undo the collet first, and then you can tighten up or loosen this ring. If I bring it to here, oof, that's too tight. There we go, that's a little tight. That's about right. And then too loose. Not enough grip on the collet. So about there. Put in the latch, and that's going to be my grip. So there it is, complete now. So that's it. Thanks for watching. I hope you have found something interesting in this video. Bye for now.